Welcome everyone. Our topic is based on boilers. Boiler is basically a closed vessel in which steam is generated by supplying heat to the water. Hot water and steam have large amount of energy even in the smallest boiler. Heat is produced from fuels such as coal, natural gas or nuclear fuel to generate steam. There are three modes of heat transfer in boiler, that is conduction, convection and radiation. There are two primary requirements of boiler, which is water must be contained safely and steam must be safely delivered in desired condition. These are the images of boilers that are used in industries. Boiler system consists of water treatment system, feed water system. On right side we have the schematic of feed water treatment system. Then we have steam system, blow down system, fuel supply system, air supply system and flue gas system. Below are the schematic of blow down system and fuel gas system. Now, steam produced by boiler is used in various industry such as in steel industry. It is used for captive power generation. Captive power plants are those which generate power for their own purpose. We generally use power blast boiler in iron and steel industry. In textile industry, steam is used for different production processes such as dyeing, drying and heating. In pharma industry, high pressure steam boiler is used due to their simplicity and efficiency, and they are the premier solution for pharmaceutical process heating. Boilers used in the pharma industry must be extremely precise, which means it should have high temperature control demands. Fulton boilers are used in the pharma industry due to their excellent construction and efficiency. In sugar industry, steam boiler is used to extract refined sugar from raw sugarcane, and the juice extracted from the raw sugarcane is sent to boiler house where juice gets heated by steam and moisture content in the sugar juice gets evaporated. By the application of steam heat, juice converts to its crystal and finally we get refined sugar.
So first way of classifying is on the basis of location of boiler shell axis. When the boiler shell axis is horizontal, then it is called a horizontal boiler. So having a horizontal axis basically means that the direction of flow of water will be in the horizontal direction. This is the water that will be converted to steam, which is the purpose of boiler. Now, which industry will use which type of boiler? In case the usage is much more and the company has a huge amount of area, then horizontal boiler is preferred because they occupy large spaces. While if the use case is small and the space available is also less, then they'll use a vertical boiler. Now coming to the diagram, we can see that the temperature gradient in the vertical direction is much more in case of a vertical boiler. Therefore, the stress induced on the horizontal castings is much more in case of vertical boiler than the horizontal boiler. Next is the classification on the basis of flow medium inside the tubes. So if inside the tubes there is water and the flue gases are outside, then it is called a water tube boiler. While if the flue gases are inside the tubes and the water is outside, then it is called a fire tube boiler. This is the most common way of classifying boilers, and we'll talk about this in details in the next section. Next comes the classification on the basis of type of draft used. So why do we need a draft in a boiler? Draft is basically used to provide air circulation inside the boiler. This air contains the fuel. So the first category is natural draught, in which a chimney is used. This chimney has a varying area, which therefore causes a pressure difference as a consequence of the Bernoulli theorem, and due to this pressure difference, the air starts to flow. In the second category, we have forced draught, in which either a forced draft fan or an induced draft fan or both are used to provide the flow of air. Now it is easy to see that natural draught boiler will be much cheaper than the forced draught, but there comes a cost because the forced draught have a higher efficiency than the natural draught. This is because the air leaving the natural draught is at a higher temperature than the air leaving in the forced draught. So this excess temperature would have been used to heat up the water, which is now being waste. Next comes classification on the basis of method of water circulation. Here we have two categories, natural circulation and forced circulation. Referring to the diagram, in case of natural circulation, water comes from section A, goes to section B, then at section C it is heated. Now this heat causes a temperature rise which reduces the density, and therefore water from section B flows to section C, thereby making the natural circulation complete. In the second case of forced circulation boiler, we have a pump additionally which regulates the flow of water. Now, in industries where we want a tighter control, we'll use the forced circulation boiler, while in industries where we do not want as such tight control, we'll use a natural circulation boiler. Next, classifying according to the furnace position, if the chamber where the flue gases are burned are inside the shell, then it is called an internally fired boiler, while if it is outside, then it is called externally fired. The shell is basically the region where water is converted to steam. Now, there are some more ways of classifying boiler. They can be classified according to their pressure, low pressure, medium pressure, and high pressure. The ranges are mentioned. Low pressure boilers are often used in buildings and designed to supply heat to individual rooms through radiators, while the high pressure boilers are used in thermal power plants. Now, according to boiler mobility, stationary boilers are fixed at one location. They are generally used for steam generation for power plants, and portable boilers, they can be moved from one location to another. The best example would be marine boilers that are used in ships.
Before going into an extensive discussion of boilers, we should know a few important parts of a boiler. Number 1. Boiler shell. It is a cylindrical vessel made up of steel plates. A boiler shell should have sufficient capacity to contain water and steam and should have the strength to withstand high temperatures and pressures. Number 2. Combustion chamber. It is a place where fuel is burnt to produce energy and needed for water steam conversion, which is generally placed below the boiler shell. Number 3. Grate. Grate is a platform made up of iron bars which are spaced apart to allow airflow, above which fuel is burnt. The surface over which fire takes place is called grate surface. Number 4. Furnace. Furnace is the actual place where fuel is burnt, and it is also called as firebox. Boilers can be classified into various categories according to contents in the tube, position of furnace, axis of shell, application, etc. The most common types of boilers used in process industries can be divided into water tube and fire tube boilers. Water tube boiler. A water tube boiler is a type of boiler in which water circulates in tubes, which are heated externally by fire. Heat is generated in boiler through a direct fired heater or combustion burner. The heat from the burner is transferred to the water tubes. As water flows through the tubes, the combustion gases heat the water and produce steam. Water tube boilers are used for high pressure processes. The rate of flow of steam is more in case of water tube boilers. Water tube boilers are generally used in power generation plants, process industries including chemicals, refining, pulp and paper manufacturing. Examples of water tube boilers are Stirling boilers, Lamont boilers, Benson boilers, etc. Few of the water tube boilers are shown here. Fire tube boiler. A fire tube boiler is a boiler in which hot gases of combustion passes through tubes surrounded by boiler water. The water and steam in fire tube boilers are contained within a large shell, and these units are usually referred as shell-type boilers. Fire tube boilers typically have a lower initial cost and more fuel efficient and easier to operate, but they are limited to lower capacities of 25 tons per hour when compared with water tube boilers. The water level within the shell must always be maintained so that the tubes are submerged underwater. Otherwise, the tubes could overheat and get damaged. Fire tube boilers are generally used in steam locomotives, small scale industries, marines, etc. Examples of fire tube boilers are simple vertical boiler, Cornish boiler, Scott marine boiler, etc. Few examples of fire tube boilers can be seen here. Now, we are going to discuss a few important differences between fire tube and water tube boilers. As discussed earlier, in a fire tube boiler, the hot flue gases are present inside the tubes and water surrounds them. Whereas, in a water tube boiler, water is present inside the tubes and hot flue gases surrounds them. Fire tube boilers are generally used for low pressure applications since the operating pressure is around 25 bar, whereas water tube boilers can be used for any application Since operating pressure is around 165 bar, steam generation rate in a fire tube boiler is low, around 9 ton per hour, whereas it can be as high as 450 ton per hour for a water tube boiler. For a given power, the floor area required for steam generation in a fire tube boiler is around 8 meters square per ton per hour, whereas it is around 5 meters square per ton per hour in a water tube boiler. The overall efficiency that can be achieved in case of a fire tube boiler is up to 75%, whereas in a water tube boiler we can achieve up to 90% efficiency when economizer is used. A fire tube boiler can work on fluctuating load for only shorter period of time. As we discussed earlier, the tube should always be submerged underwater due to the risk of heat damage, whereas water tube boilers can work on fluctuating loads for any period of time. The direction of circulation in water tube boilers is well defined, whereas it is not well defined in a fire tube boiler. Fire tube boilers has a simple mechanical structure and hence has low capital cost, whereas in case of water tube boilers, it has a complicated mechanical design, hence the capital cost is high. Operating and maintenance costs are low for a fire tube boiler when compared with a water tube boiler. Even though chance of bursting are low in case of a fire tube boiler, there is a greater risk of damage when compared to a water tube boiler which has higher probability of bursting. Water tube boilers are modular, hence, those parts which are damaged during bursting can be replaced, which is not the case for a fire tube boiler. Even though water tube boilers are heavier than fire tube boiler, the transportation and initial setup is easy for a water tube boiler due to its modular nature.
So now let us talk of performance evaluation of boiler, which is the most important aspect in an energy industry. Boiler efficiency is coined as the efficiency which is the percentage of the heat input that is effectively utilized to generate steam. In this boiler theory, what we can do is we can split these method into two types: direct method and indirect method. The direct method is where the energy gain of the working fluid is compared with the energy content of the boiler fuel, while in the indirect method, the efficiency is calculated between the heat losses and the energy input. Boiler efficiency help us to find out the deviation of boiler efficiency from the best possible efficiency and the target problem of for a particular corrective action. So that's why we study efficiencies. Coming on to the first method, which is the direct method. So this method is basically the efficiency which we were calculating in the UG level thermodynamic courses, which is basically the input output method, such that the amount of heat which is given to the boiler and the amount of heat which is generated by the boiler in the form of steam. So what we can calculate from the boiler efficiency and how to calculate is like, suppose we want to generate this amount of steam per hour. So that particular amount of steam will have certain latent heat, which will be the which when multiplied with the amount of steam into the latent heat will give us the total heat output of that boiler. Plus, this heat is generated by the particular heat input to the boiler. That heat input is determined by the fuel, how much fuel we are burning. So this ratio to the amount of steam generated to the amount of fuel that is being inlet, both in terms of energy. This ratio is termed as the boiler efficiency, which is particularly known as the direct method of calculating the boiler efficiency. Another method of calculating the boiler efficiency is indirect method, which is also called the heat loss method. So the method is simple. What we assume is, suppose 100% energy is given to the boiler as an heat input. So now we calculate amount of heat losses that are occurring in the in the boiler. So these heat losses account to the incomplete combustion of fuel. This may be account to the convective and radiative heat losses, loss of heat due to moisture in fuel and combustion air, loss of heat due to combustion of hydrogen. So these are the losses which we account for in indirect method, and then we subtract it by 100. So basically we calculate the percentage losses and then we subtract this from the 100% fuel input, which gives us the efficiency of the boiler, and this is known as the indirect method of boiler efficiency. Moving on to the principle of operation of boilers. So boilers are a heat exchangers which merely use the heat transfer modes of radiation, convection and conduction to convert the heat energy which is coming from fuel to convert water into steam. So proper boiler operation demands a proper process control. Suppose in this figure, what we see is that this is a drum which is a boiler, and then there is a water. So what we need for a process for a particular process control is we need to maintain this level of water. We need to maintain the heat which is being input. We need to regulate the amount of water which is being feeding into the boiler, and the amount of the pressure which is in the boiler in order to generate the particular amount of steam at a particular saturation temperature. So in order to illustrate how boilers work, or just to give a basic brief idea about how boilers are working, a simple boiler consists of a heater, and in that heater there is a fuel which provides thermal energy to the shell. It consists of a water drum, which we can say as a cylindrical vessel. It consists of a water inlet, a steam outlet. The water comes into the boiler. Due to the thermal energy from the fuel, the water gets superheated, and then it converts into steam, and then that steam is taken out and is sent to another processes for cogeneration. So the steam forms after the water is sufficiently heated as the steam leaves the vessel. So in this process, water is also being evaporated. What we can say, water is boiled off. So what we need is we need to maintain the circulation of water inside this. So a particular makeup water is being sent at a proper interval of this boiler in order to maintain the level. So what I have talked is of the process control. We need to maintain this level. We need to maintain the flow. We need to maintain the pressure and temperature of the boiler, which is operating here. Talking of water circulation in boilers, what we can say, due to the presence of free convection, so the low temperature water comes to the pipe, to the downcomer, which is at low temperature. It goes into the drum, which in the mud drum is again heated, and this water, after being heated, rises through the riser, and then it goes into the boiler again. So what happens? Recirculation is maintained in the boiler. So what it does is low temperature water comes in here, and then a high temperature water goes out from there. So with each pass, the temperature of the water increases. As the temperature of the water increases, this water starts to generate steam bubbles, and the steam gets collected in the steam drum. So through the continuous recirculation of the water, what happens is after a certain particular steam is collected, the pressure of the system starts to rise, which gets to the increase in the boiling point of the water. So then what happens is what we do is we let go of the steam after a certain particular pressure is achieved, at which we want to generate that particular steam. So this is how a boiler. This is how in boilers water circulation is maintained. So in any process or in any industry which demands steam, be it a nuclear industry or a nuclear power plant, any industry requires a boiler. So where does that water comes from? So the merely answer is they take water from lake, rivers, wells, or an ocean if the industry is on a coast. But the thing is, we cannot use the water taken directly from the river, lakes, wells, or sea. So the thing is, because of the impurity present in the water, which may lead to bad maintenance or bad performance of boilers. So what we do is we perform several steps. So for this process, many industries or many power plants have a particular small setup known as the demineralization water plant, or known as DM water plant. So what it does is, first of all, the water is taken, and then the cleaning of water is done by the process of removing suspended solids, by the process of filtration and sedimentation. After the water is cleaned by the suspended solids, what we do is we remove minerals. So this step is basically, as it sounds, is we remove minerals from the raw water or from the clean water by the process of softening demineralization, which is an ion exchange process, and reverse osmosis, which is a membrane separation process. So individual industry, or depending upon its process economics, will opt for individual methods. So then after removing minerals, cleaning the water, this water is step further into removing the oxygen. So the dissolved oxygen in the water, even though water has removed minerals, even it is clean, may cause a problem, which is corrosion, and which may lead to bad performance of a boiler, as we have studied in heat transfer process, called which is coined as fouling. So what we do is we remove oxygen from the water, and then this step includes phenomena such as deaeration and oxygen scavenging. So the most popular in nuclear industry or the power plant is deaeration. So what we have is we have large deaeration chambers or containers in which the water is deaerated. The air oxygen has been is removed from this water. Then this particular water, after the deaerator, is known as the boiler feed water and then is fed to the boiler for generation of the steam.
Now we know that in order to produce steam, heat is supplied to water and this heat is generated by combustion of fuels in the presence of oxygen. Fuels that are used in boilers include solid fuels such as coal, lignite and charcoal, liquid fuels such as high-speed diesel and light diesel oil. Gaseous fuel include natural gas and biogas. Agro waste such as baggies, rice and groundnut shell. In coal boilers, we use coal as a fuel to heat water and create steam for energy production. The steam is produced under tremendous pressure which flows into turbine and spins the generator to create electricity. Coal is preferred in comparison to other fossil fuels as its boiler efficiency provides lower operating cost and it is one of the cleanest fossil fuel that are available today. Coal include solid fuel such as anthracite, bituminous and subbituminous, and bituminous coal is widely used for the generation of electric power. Another type of fuel that can be used is biomass. It is the renewable organic matter. Examples of biomass include fast-growing trees and plants, wood waste, agricultural crops, and industrial waste. Biomass boilers are used in pulp and paper industry. These boilers run on various types of wood fuel such as wood pellets, logs, and wood chips. Wood pellets biomass fuel can be packed and delivered in bags or bulk and buying in large quantity at once will be cheaper. Whereas wood chips biomass fuel are more expensive when it comes to transportation as they are less dense compared to pellets. Advantage of wood chip is they produce less ash and are smoke residue.
Next, we discuss a process called boiler blowdown. It is a removal of water from boiler, and the purpose is to clean the boiler and remove dirt, oil molecules, and various precipitates that might have formed due to chemical addition to the boiling water. It also helps reduce the water density and remove excess water if present. It is done in two ways, manually and automatically. Manual blowdown is useful to remove sludge formation or suspended solids. It has its drawbacks, the major drawback being loss of heat and pressure as the hot water is taken out. Continuous blowdown is done automatically with the quality of feed water and quality of water inside the boiler being continuously checked for impurities. It removes maximum impurity with minimum heat being lost, so this is an advantage of using continuous blowdown. Now let's see what are the common factors that can lead to a boiler hazard. Low water levels caused by faulty low water cutoffs can cause the boiler to deform, melt down or even explode. Excessive pressure in a boiler can also be dangerous. A boiler is designed to work at a certain pressure, and if pressure is allowed to build up in a boiler, it can explode. Fuel-related accidents, that is, a leak in a fuel valve or inability to purge the combustible gases, can also lead to an accident. A boiler explosion can be very dangerous and can even destroy buildings. Here is an example of a boiler explosion. On 1st July 2020, a boiler in Unit 5 of the Thermal Power Station 2 of the NLC India Limited in Tamil Nadu exploded, claiming 13 lives. Just 2 months before, a similar accident happened in a different unit of the same plant, claiming 5 lives. The reasons for the accident given by the officials were overheating and high pressure in the boiler. The basic safety devices used in a boiler are discussed here. Safety valves, the most important safety device in a boiler, which are typically used for boiler overpressure protection and other applications such as downstream of pressure reducing controls. It relieves internal pressure if a failure occurs in the system. It is a simple device and is affected by corrosion and restricted flow within the valve. Water level control and low water fuel cutoff, which are combined together by many systems. These ensure that the water level does not fall below a predetermined level and shuts the boiler down in case that situation occurs, And lastly, the water gauge glass, which is used to verify the actual level of water in the system. Sludge buildup can lead to faulty indications of the above. There are various health hazards of working in a plant. Physical hazards include excessive continuous noise levels, heat stress due to working in high temperature and highly humid environment, potential exposure to radon and electric shocks. Chemical hazards include irritation of eyes, respiratory tracts, and skin. Asbestos, which can cause cancer, and exposure of fuels, corrosion inhibitors, and other additives, which can cause dermatoses. Biological hazards like development of fungi, bacteria in the boiler, and presence of rodent and insects which can cause infectious diseases. Accidental hazards includes falls or slips due to slippery floor caused by oils, water, or fuel. One can also be struck by falling objects or be burned from hot surfaces. We now list the possible opportunities to conserve energy in a boiler. Feed water preheating. Fuel gases leaving the boiler can be at temperatures of 200 to 300 degrees Celsius. Thus, this heat can be used to preheat the feed water. Next is if we preheat the combustion air. If we raise the temperature of combustion air by 20 degrees Celsius, efficiency can be increased by 1%. We must also ensure complete combustion of fuels. Incomplete combustion can be due to shortage of air, surplus of fuel, or poor distribution of fuel. Next is excess air control. Excess air is needed for complete combustion to allow for the normal variation in combustion and to ensure satisfactory stack conditions. Optimum excess air for maximum efficiency is when sum of losses due to incomplete combustion and loss due to heat in fuel gases is minimum. We can also minimize radiation and convection heat loss by repairing and augmenting insulation. Then comes the proper boiler scheduling, that is, it is more efficient to operate a fewer boiler at higher load than more boilers at low load. Continuous blowdown can be wasteful, hence controls should be installed to respond to boiler water conductivity and pH, that is, blowdown to happen only when required. Scaling and soot buildup should be removed regularly as it can act as insulator against heat transfer. Reduction in boiler steam pressure, if permissible, can reduce fuel consumption. The maximum efficiency of boiler is at about two-thirds of the full load and it decreases if the load is decreased. Thus, operations of boiler below this level should be avoided. Boiler should be replaced for better efficiency when it becomes old and inefficient or is not capable of firing cheaper substitution fuel or is over or undersized for present requirement or is not designed for idle loading conditions.